Oh my gosh, you guys, we're here. We finally did it. I'm Mrs. Applegarth, and this is Chapter 1, Section 8. We're going to talk about perimeter, circumference, and area. And here's the fun part. Perimeter and circumference, kind of the same thing. All right, so you guys, I want you to draw and label the shapes and write the formulas. Okay, we have ourselves a square. A square has the same measures for each side. Let me get a pen. We are going to call that S, and technically they are all S's. So the perimeter of a square is what we get when we add all the S's together. Well, let's just add them. 1S, 2S, 3S, 4S. So the perimeter we can write as 4 times S. If you don't remember this and you just remember perimeter, add all the sides together, that will get you into the same boat as going 4S. Our area is the side squared. Remember, squared just means side times side. So it's one side times itself. Okay, make sure you write those down, my darlings. Get that, and we do want the square as well. Okay, our next friend is a close relative of the square. He is the rectangle. He has 4 sides, each with a 90-degree angle. We typically mark a rectangle as length with a lowercase cursive L, and then a width. The reason we do the lowercase cursive L is because a regular L looks like a 1. So we usually transition anything with an L, we lowercase cursive. So the perimeter, so the distance around, which is perimeter, the distance around our shape is going to be a W, an L, a W, and another L all added together. And when you put that together, it becomes 2 times W plus 2 times L. Since we have a W on the left and a W on the right, there's 2 of them, a length on the top and a length on the bottom. And then our area is length times width. Okay, make sure you guys are writing those down. Everything that is highlighted gets to be written down. I guess we should write the word square as well, so we know what it's called. All right, next we have this crazy little guy called a triangle. And triangle has the side lengths, and we'll put that in. A, B, C. Oops. We usually like the B to be on the bottom, so we'll go A, B, C. Okay, and then from the very top to a point that's perpendicular to the base, we call H, or the height. So perpendicular means the same thing as right angle. So if you're perpendicular, you're making a right angle. I don't know why, like it feels like the same amount of syllables, perpendicular, right angle. So I don't know why we choose one over the other, but perpendicular sounds really mathy, and so we're gonna roll with that one. Okay, you guys, make sure you draw your triangle. It's got 3 sides. It has got a height and an A, B, and C sides. Okay, so when we're trying to find the perimeter of a triangle, we're just going to add all the sides together. A plus B plus C. When we're dealing with the area, we're going to take our base times our height and cut it in half. When I put this in my calculator, I usually will go base times height and then divided by 2. If you want to do 1/2 times base times height, you can. But I find the dividing by 2 to be the easiest. Okay. All right, you guys, make sure you're writing these down. Let's write triangle, its area, its perimeter, and then the picture. Next, we have this guy. He's got no sides. He is a circle. He has a radius. Radius is halfway across the circle. It is the diameter divided by 2. We're going to label radius R. Okay, so we're going to go the perimeter of the circle is also called the circumference. So when it comes to a circle, think about this is like the first couple words in circle. Circle, circumference, it's the same thing as perimeter. It's as if we are sitting on this part of the planet and we go all the way around our sweet planet Earth. How far have we traveled? Well, let me tell you, it is 2 times pi times r. Pi is a number that's approximately equal to 3.14. And in your calculator, if you're in scientific view, pi lives right here. So it's like 2 times pi times whatever the radius is. Okay? So pi is usually its own little button on the calculator. If you have a scientific calculator at home, yours has a pi. If you don't have a calculator, go ahead and use 3.14. Just be careful because we may need the rounding issues may come into play. Okay, the area of a circle is pi times the radius squared. So if you have the radius, you have everything you need to find the circumference and the area. That's why I love the circle, because you only need the radius and you have all of its information. It is amazing. The other one's a rectangle, I guess a square. If you have this side, you'd have everything. Okay, so make sure you put circumference and area. Woot woot. Okay, let's do some practice. We're going to find the perimeter, the circumference, and the area for each of these items. This is very work intensive, so the rule stands that you have to show your work. I'm going to write it down. I would like you guys to draw the picture. Put the dimensions on each one. So this is A. Make sure you're drawing the pictures. C, the triangle. D is a crazy guy. We will see how to deal with him in just a minute. He is neither anything. Okay, so once you draw the shape, we can actually find the perimeter. Please write the formulas until you have them memorized. That way they just won't come out of nowhere. Okay, so the perimeter is 2 times the width plus 2 times the length. So that is 12 plus 22. It's 34 for the P. The area is length times width. Okay. Make sure you guys write those down. You need the work and the answer. Work and the answer. All right, B. Yay for B. We're going to find the perimeter, which for us is the same as circumference. That is 2 pi times the radius. We see here, because it only goes halfway across the circle, we see that the radius is 5. So it's 2 times pi times 5. If we want an exact solution, then we combine our numbers together and we let pi chill on its own if we want an approximate, which is the wigglies. We do that in our calculator. We go 10 times pi, 31.4. Okay. And then make sure you guys write that down before circumference. Combine the numbers together, the 2 and the 5, to make 10. And then if we want to approximate it, we change that equals into a squigglies. We're going to do the area on this one. Pi r squared. Pi times 5 squared. 5 times 5 is 25. Usually we put the numbers in front of the pi. So the exact area is 25 times pi, and the approximate area, when we multiply it out, is 78.5. All right, you guys make sure you're showing your work. Without the work, you will not get credit. All right, let's check out this little triangle here. His perimeter is everything on the outside, so that's 8 plus 4 plus 10. I said it completely backwards to the way I wrote it. That's okay. 14 plus 8 is 22. And that's the perimeter. Easy peasy. Add all those together. And then the area is 1/2 base times height. And let me show you how I prefer to do that in my calculator. So I like to do the 10 times 3. And then the way I deal with the 1/2 is I divide by 2. That's 15. You could also choose to do 1/2 times 10 times 3. That works too. You could know that this is 0.5, and you can go 0.5 times 10 times 3. I'll get you back to the same answer, so I'm okay with whatever. So that's 15. Okay, last but not least, we have this crazy bird. Make sure you guys are writing down the work and the answers. Okay, now we have this crazy bird. This crazy bird here, we are going to split up into 2 shapes that we already know. So if I drop a line kind of like right here. Okay. And now I have a rectangle and I have a triangle. This triangle, you may not think you know what the dimensions are, but actually we do. So if from here to here is 10, From here to here is 14, but from here to here is 10. That leaves us 4 for this triangle. And if from here to here is 3, then from here to here is also 3. What? And just because life is super sneaky, we are going to Pythagorean Theorem this value right here. So it's going to go, Pythagorean Theorem is a squared plus b squared equals c squared. A is 3, b is 4, c is, I don't know. 3 squared is 9, 4 squared is 16, c squared is, I don't know. 9 plus 16 is 25. And then to solve for c, we take the square root of both sides because opposite of squaring is square rooting. And now we know this guy is 5. Okay, so circumference, here we go. Our perimeter. I'm going to erase 10 right here. Okay, so our perimeter is 3 plus 10 plus 5 plus from here to here is 14. 3 plus 10 is 13. 13 plus 5 is 18. 18 plus 14 is 32 is our perimeter. Centimeters. We have actually like units on this one. Okay. So now we're going to find the area, and we can't just find the area of one of these things because it's a rectangle and a triangle. So we're going to find the area of the rectangle and add it to the area of the triangle. So we're going to find both. Area of a rectangle is length, which is 10, times width, which is 3. And area of the triangle is 1/2 base times height. Okay, so our area is 30 plus 6, just so that you believe me. So it's 4 times 3 divided by 2. 6. Okay. And so the area of our combined shapes is 36. Okay, so let's go over that because it's good for you. The first thing we did was we found this extra missing side by using Pythagorean theorem. We did 3 squared plus 4 squared equals c squared. We got 6 plus 19 equals c squared. We got 25 equals c squared, and we got c equals 5. Then we found the perimeter. We added up everything on the outside, the 3, the 10, the 5, and the 14. We got 32. Our area, we knew that it was the area of the rectangle plus the area of the triangle. So we said 10 times 3, which is length times width, plus 1/2 base times height, which is what our triangle one is, which gave us 30 plus 6, or 36. Okay. We have a few more example problems. Find the area of a triangle with side lengths 5, 12, and 13. So let's draw a picture, always. We'll make this 5, we'll make this 12, and we'll make this 13. Area of a triangle is 1/2 base times height. We have an issue here because given the numbers, we don't really have a height. So one thing that we're going to look at is we're going to see if this is a right triangle. So we're going to go our two smallest sides squared. Do they equal our largest side squared? If they do, then we have a right triangle. And then we can use 5 for our base and 12 for our height. So if you have a right triangle, then you can use 5 to be the base and 12 to be the height. So on a right triangle, the base and the height are on the, they're the side lengths because of the perpendicular boop, boop, right angle. 25 and 144, oh, it is 169, and that is equal to 169. So this is a right triangle. When the Pythagorean theorem works for you, it's a right triangle. So we can say that the area is 1/2 our base of 5 and our height of 12. 5 times 12 is 60, divided by 2 is 30. So this is a little bit more involved than it first looks. We have to decide, is it a right triangle? We give it the Pythagorean theorem test. When we find out yes, then we use 5 as our base, 12 as our height, and we get that our area is 30. Okay, guys, 2 more examples and then we are done. Find the area of just the shaded region. So we're going to take the area, we're going to take the area of the rectangle and minus out the area of the circles. It should be pretty easy, except, oh my goodness gracious, I don't have a length or a width. Oh no, what am I gonna do? And don't feel bad if you see this problem in the wild and you don't know how to do it. Don't feel bad. It took me like 20 years to figure this stuff out, which is what makes me a good teacher for people who struggle with math. Okay, so if our radius of a circle is 4, that means this radius right here is also 4. And this is 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 4. So when they give you a radius of a circle, they really give you a lot of information. So all together, this whole 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, plus 4 is 24. So we know that the length is 24. Now if we turn our circle sideways, oh, it's already turned sideways. We can see that this is a radius of 4. This is also a radius of 4. So this is going to have a width of 8. So now we have all the information we need. We're going to take the area of the rectangle, minus out these 3 circle areas, and be left with just the shaded region. So the area of the rectangle is length times width. The area of the circles, there's 3 of them, is pi r squared, because there's 1, 2, 3 circles. Okay, so let's fill in those numbers. The length is 24. The width is 8. minus 3 pi. The radius, again, back to the beginning, is 4. 4 squared. Okay, I'm getting my calculator, calling in the big guns. 24 times 8 is 192. 4 squared is 16, and 3 times 16 is 48. So we combine the numbers together, 3 times 16, which is 48. And then we stick the pi on there. This is the exact amount. We're also going to do an approximate amount, just for fun. So we're going to go 192 minus 48 times pi equals 41.2. So we get an exact and approximate. Okay. Actually want you to put this down on here. So knowing that each of these radii are 4 is important. And that this radii is also 4. That's important. Having the width is 8 and the length is 24, super important. Knowing that the area of the rectangles minus the area of the circles is also important. Length times width is the area of a rectangle. Pi r squared is the area of a circle. We have 3 circles, so we're going times 3. 24 times 8 minus 3 pi 4 squared. Knowing that the exact answer is 192 minus 48 pi, and that the approximate answer is 41.2. Yay! 2 more examples. We are done. All right, Tom hiked south. I love these ones because they just hike in straight lines and it's awesome. Okay, so Tom hiked, so this is T for Tom. He's here. He hiked south 7 kilometers. He then turned west. Never eat shredded wheat. He then turned west and hiked for 4 kilometers. I don't know why 4 is so much longer on the map than 7. And then he turned north and hiked 3 kilometers. How far is he from his starting point? T. So we need the distance from here to here. This is kind of like our crazy problem we did here. It's that same rectangle shape with a triangle on the end. So we're going to use that same method and a little Pythagorean theorem. I'm not drawing that very straight. Okay, so this is a straight line. Okay, and then here's our little right angle. So this whole thing was 7. So this whole thing was 7. I'm going to put it back because I guess I'm just going to draw it. This from here to here is 3. And then so this has to be what's left after I take up 3 of the 7. Okay, this distance is 4. So this distance here has to also be 4. It's like a little rectangle. So if this is 4, then the top is 4. So then I look at, I've got a nice little rectangle. He is 4 by 4. And I want c squared. So 4 squared plus 4 squared equals c squared, because that's this distance here, c. So that's 16 plus 16. That is 32. And the square root of 32, what? Because you have to square root it. Well, we don't know what the square root of 32 is, so we're just going to have to find it. Is approximately 5.66. So let's make these guys squiggly because we are approximating. Kilometers. Awesome. So we just, to recap, we drew a picture. We went 7 miles south, 4 miles west, 3 miles north. How far away from our starting point are we? If this whole thing is 7, this little snippet is 3, then what's left for our triangle part here is 4. If it's 4 on the bottom here, it's got to be 4 on its top of our rectangle as well. That translates into a 4 here. We're trying to find this distance c. So we're going to use Pythagorean theorem when we have a right triangle. So that's 4 squared plus 4 squared equals c squared. 16 plus 16 equals c squared. 32 equals c squared, and we're going to square root both sides. 5.7 kilometers is our approximate distance. Okay, dokie. We're going to do a triangle, and I am going to get a grid. So watch out. Grid, your graph. Right. Gridding it out. You know, it puts it up here, so we got to sneak it down low. Very particular about moving. Okay. So our first coordinate is A, and it's at 1, 4. So that is over 1, up 4, boom, right here. Guess I'll put a dot. Make sure you label it. I know it seems like a pain in the butt to label it. B is 1, 1. And C is 7, 1. Over 7, up 1. Okay, and it says find the area. So really what we need to do is, this is the base, this is the height on a 90-degree triangle. The height is the side length. So the area is 1/2 base times height. Here's the beauty of graphing it. We can count. So the base is 1, 2, 3, 4, 5. And the height is 1, 2, 3. Half of 15 is 7.5. All righty then. And that finishes us off for this week. Thank you guys so much. I know it's a 35-minute, it was long, arduous, Um, so our secret password today is going to be Pythagorean. So let's find Pythagorean Theorem. I think I did it over here. Sorry. I didn't. Okay, let's write it down. Pythagorean Theorem. Boom. Alrighty. Thank you guys so much. Let's make sure. Oh, it wants it capitalized. Okay. All right. Have a good rest of your day.